Okay, so number 16 from page P13. Page P13, number 16, is a pretty picture, but it gives us the equation, so that's good. So I'm just going to write the equation on here.
Do we need to look at the picture at all, or can the equation?
The picture can help you figure out what points to use, which is always true. And actually, we may, if nobody even asked about one, we may do one of the ones from 2 through 12 and make you use your graphing calculator to help you.
I'm about to ask about 4. So.
That's great. Look at that. So the equation is f of x equals 5x squared plus 3x minus 2. Okay. So we are supposed to figure out whether it's got a maximum or minimum value, find the value of it, and state the domain and range. Okay, so this one already gives you a picture, and so you can, even if it didn't give you a picture, we can tell just from looking at this whether it's a maximum or a minimum. What am I looking for to decide to know whether it's going to be a maximum or minimum?
The constant?
Not the constant, but yeah, so the A, the leading coefficient, which may have been what you meant. The constant would be this one. So this one, is it positive or negative? So what shape is this making? What does it look like? It's open. It's a parabola opening up, yeah? Okay, so this is a parabola opening up, so it has a minimum, right? So minimum's first answer, easy peasy. And it also gives you the picture. So from that and the picture, two ways from Sunday instead of 6 ways from Sunday, it has a minimum, right? There we go. Yay. First answer down. Easy peasy. Got some points already. Now, we need to figure out where the minimum is. So what part of the graph, what is the name for the point that is at the minimum? The vertex. So that's what we're going to use to find it. So we need to find the vertex of that. How do we find the vertex from standard form?
Start with negative b over 2a.
So to find the x part of the vertex, we're going to do negative b over 2a.
2 times a.
That is what, yeah. So what am I going to put right here?
Negative
3. What am I going to put right here? 5. Okay. So this equals negative 3/10. Right? Okay. So that's not the minimum. Yeah, so we've got to find the minimum by finding the y part. So we're going to take this and we're going to plug it in to x, right? So we're going to find f of negative 3/10.
Do you square the thing first, or do you multiply?
You square it first. Don't put that in your calculator. You got this in your brain. What is negative 3/10 squared? 900. Look at you, so smart.
Negative 900.
No, it's not. It's a good question. What's a negative times a negative? Positive. So when you square a negative, it turns out positive. So 5 times 900.
9/20.
What?
9/20.
It is not 9/20. That's not true. You said it right a minute ago.
What are we talking about?
900. Oh, this is 9/20.
Yeah.
Yes, it is. You're right. That's correct. I thought you were, yeah. Never mind.
I'm not breaking, I promise.
You're not breaking this time. Okay. So minus 9/10 minus 2. This is 9/20 minus 18/20 minus 2. Punch that in your calculator, or we can continue on this way. Somebody have an answer for me yet?
Negative 49.
Negative 49 what?
20th.
Negative 49/20.
Wait. Is that correct?
I just converted this to having the same denominator. It's 9/10. Because 3 times negative is, yeah. I was just proceeding with doing it by hand. But okay. Negative 49/20 is the minimum. Yeah. Now, our book gives us a decimal equivalent of that. So it's 2 point something. Probably, what did the book say? 45, right? Negative 2 point, I don't remember. Wherever it is, 16.
Negative 2.45.
Yep, that's what the book says. So, there it is. Now, so what is the domain of this function?
All real numbers.
All real numbers.
And how do we know that?
What shape is this?
Parabola.
It's a parabola. What is the domain? What does that mean? Yes, x part. It's what x can be, the set of all possible x's. So does this ever stop going to the left?
No.
Does it ever stop going to the right? So the domain is all real numbers.
Okay.
Okay. So,
You're right that it was the arc with like the double.
yes.
Right. Okay, so it's always going to be, the domain's always going to be all real numbers unless it states like the ending point.
So a parabola, yeah, will always be all real numbers unless it's a word problem. And then typically we restrict the domain because it's like if it's say a physics problem and it's a two-dimensional motion thing and the thing is going over here, then the cannonball stops when it hits the ground. It doesn't keep on going into the earth forever. So in a word problem, we restrict the domain to this thing. But a parabola, generally, the domain is all real numbers. So the range, on the other hand, what is the range?
Greater than or equal to the minimum, which is negative.
Yeah.
How do you get the y is greater than or equal to part?
What does range mean? Why? What other questions do we have?
1d6.
You lied. You said you were about to ask about 4.
Well, that's tight.
Oh, okay.
Straight up forgot to do 26.
Well, there you go. Okay. We're
No, I didn't. It's right there. I just had it written on a separate thing. Alright.
there.
I rarely have to write things down anymore when I factor. But 26 I had to write stuff down because it was.
It was
Yeah, you
wild.
figure out factor. That's my problem.
I can't just look at it and be like, boop. Yeah. Is it not factored out as w plus 5 and then
26
4w
is-
minus 1?
What did you say?
W plus 5 and then 4w minus 1. Yes, that's right.
Yeah.
Then how in the heck did I get the answer wrong?
Because you didn't finish it. You did everything right. You just didn't get the answer.
No,
Yeah.
I did the subtracting thing.
Well, you said you factored it back.
Oh, I forgot to divide by 4. That's what it was. Never mind.
Ah, there you go.
Yeah.
All right. So 4w squared whatever else is happening plus 19w minus 5 equals 0. We're supposed to solve for w. What do we need to do? 2 parentheses, because it says to solve by factoring. I probably have to say this less in pre-calc, because y'all probably at least sort of know how to factor by now. This, like when we do systems or whatever else, if the instructions on a test or whatever say solve it with this method, and for some reason you can't solve it with that method, but you can solve it with the other another method, solve it with the other method, and you'll still get most of the points. You just won't get them all, right? Okay, so factor this, 4w and w, and then 1 and 5, we're going to do a nose and a mouth and put 1 and 20. If you subtract that one and add that one, then we're good to go.
I'm so dumb.
And then when we solve each one of those little things, you get 1/4 and -5. We are in pre-cal now, you know, and this, you know, we did this. We did this with some things in Algebra 2. In fact, I've already said it in this year's Algebra 2 class, as it is now, if you can do it without making mistakes consistently on it, it is now a safe plan if you want to and you can to skip some steps. So if you can go from here to here, which you can, everybody in this room can go from here, because if this is not a 1, it's going to be the opposite sign of this, yeah? If it isn't a 1, it's always going to be the opposite sign and this divided by this, always. So I'm not saying you have to. I'm not necessarily even encouraging you to do so. I am telling you that when I go to grade your paper, I'm not going to get annoyed when you do that, which doesn't really affect you. But I am giving you mental permission to kind of do some of those things. And you might think, well, he's giving me permission to be lazy. I'm not actually. What I'm actually doing is I'm encouraging you to start using your brain in a different way. So if you want to do that, you are welcome to on some things like this. Okay? What other questions do we have?
So the reason I couldn't factor it is because I was trying to add the two. I was trying to add.
Oh, yeah.
And I was like, there's just no way to get to 19. How do you?
Right. You forgot about the smiley face bit.
Mhm.
Yeah. Okay. What other questions do we have?
20.
20.
We just did one like 20. Yeah, with 16 and 24. 17.
Okay, let's do 20.
I got the answer right.
Okay, so for 32, p squared minus
3p minus 8.
Okay, so we're supposed to solve using completing the square. So we got to remember how to complete the square. That's what we got. That's our first task, right? Got to remember what it is, why it is, how it is, all the things. Anybody see where I set my marker, my black marker? Who knows? Right here, right in front of my face-ish. Okay. All right. So, 2. No, I said 36, 32. She said 32, and I wrote 36. Okay. Yeah, what do we do to complete the square?
First, you move
separate.
88 to the other side.
Yeah, move him over. So we end up with p squared minus 3p equals 88.
And then we do the green part.
We do the green part. So what is the green part?
B over 2 squared.
B over 2 squared. Negative 3 divided by 2 squared.
Why is that called the green part?
Because of Ryland and the waters.
Okay.
It's not an actual thing.
Then why are we doing this as part of the equation? No, that's.
No, so why is it called the green part? That's why it's called the green part.
No, why are we doing it to complete the square? Why is it?
Because this is the completing the square. That is what doing this is. We are forcing this to be something that comes out to a perfect square. All right? And so the green part is this formula. B divided by 2 squared. So and we know that this is B, right? So it's this divided by 2 squared. Right? So squaring that, we get 9/4. Right? So now what do we do?
Now
Stick it in.
Yeah, we stick it in. We add 9/4, and we can't just randomly add 9/4. We have to do something else. What do we have to do?
Add to
put
the
it on
side.
both sides?
Yeah, put it on both sides, plus 9/4. Now what do we do?
Now we make the left a square.
Now we factor this. Okay, you're like, oh my gosh, factoring 9/4, but it's actually easy to factor because it always factors into this one before we square it. So it always factors into that, always. Okay? And then what's 88 plus 9/4? Somebody punch it real quick. 90.25. Now we got fractions and decimals and whatever else. So rude. Now what do we do?
Unsquare.
We do unsquare, and actually if we were in Europe, that's what we'd call it. But here in America, for some reason, we call it square root. Dumb.
I like unsquare.
Unsquare is a better name.
What is the root of the square?
Something. Unsquare is a better name.
How do you?
We would be better off not doing 90.25 here, because we probably could have done it in our head. What is 90.25 as an improper fraction?
90.
Not a mixed number, an improper fraction.
361 over 4.
361 over 4. Because here's the deal, ladies and gents. We are in, oh, this is 32. We are in pre-cal. We are not in algebra 1, we are not in geometry, and we are not in physics or chemistry. And so, always, unless we're doing a word problem and we need the decimal equivalent, now this one actually comes out to be a pretty whole number answer, or integer answer or something like that, but if that wasn't true, we always, in just regular problems, want the most reduced exact answer possible. So, if we have the square root of 6 or something, or square root of 5, or the square root of 17, he stays the square root of 17. He does. If we do the square root of 6, we don't end up with 2 point blah 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 blah. We don't want that ugliness. We want it exact. Because we are the mathematician hat. We give the engineer our beautiful answer that's perfect and exact, and then they can take it and mess it up however they need to mess it up. Okay? So now this one gives us a pretty answer. What's the square root of 361?
19.
19. And square root of 4, we don't even need our calculator for because that's just 2, yeah? Now, oh, I forgot something because I got distracted telling you all other things. When we take the square root of both sides, we end up with what? Plus or minus. So we end up with p minus 3/2 equals plus or minus 19/2. And then we add 3/2 to both, excuse me, add 3/2 to both sides, and we get p equals 11 and negative 8.
Not the one, no, I got -1 the first time.
Oh, you don't combine those?
We do. 3/2 plus, oh, you don't combine these?
Yeah.
No, they're two separate answers. A comma is not a combine.
And the minus.
Yeah, it's the positive one and the negative one. There's nothing there. Yeah, comma is not an operation. It's a comma. We expect two answers because it's a quadratic. It's a degree 2 polynomial.
Why are they different numbers then?
Because 3/2 plus 19/2 is 11, and 3/2 minus 19/2 is negative 8.
Okay, how do we do 34?
Magic, probably. Same way, but we can find mistakes. Here we go. Or possibly the end, maybe, I don't know. 34. (34) is 3g squared minus 12g equals negative 4. And we're supposed to solve this one by completing the square. We've already moved the thing over, so now we do the green part, yeah?
Doesn't A have
Oh yeah, you're right. My bad. I was too excited. We can't complete the square yet because a doesn't equal 1. It's broken. So what do we got to do first?
Divide
That's-
everything by 3.
Helpful thing to remember.
It is a helpful thing to remember. Divide everything by 3. So now we've got g squared minus 4g equals negative 4/3. Now we do the green part.
And you do the green part of the second
Yep.
one, right? Okay, go.
Negative 4 divided by 2 squared. So negative 2 squared, which is 4. So we add 4 to both sides. And then we factor. It always factors into this one. So we've got g minus 2 squared equals 8/3. I was going to get there. You just beat me. You probably already punched in your calculator yesterday. Yeah. All right, now what do we do?
Square root it.
Square root it. And when we square root both sides, we end up with plus or minus. So we've got g minus 2 equals plus or minus the square root of 8/3. I'm going to go ahead and write that as the square root of 8 over the square root of 3.
Oh yeah, I got some.
Will I get points if I don't do that?
Well, you're going to have to do that because we don't want that square root in the denominator. So we're going to have to get rid of it. So, yes. Okay, so what?
And how do we proceed with that?
Well, we're going to add 2 to both sides real quick and deal with that.
And you're looking for perfect square, right?
Not yet, but we will be. So now we've got g equals 2 plus or minus. I say, well, let's go ahead and deal with that now, yeah? Okay, how do we get the square root 3 out of the denominator? Remember how to do that?
Do you multiply the whole thing by 3?
Not,
Square root 3?
yes. So we multiply it by square root of 3 over square root of 3. So multiply times square root of 3 over the square root of 3. Because the square root of 3 times the square root of 3 is the square root of 3 squared, and what happens to the squared and square root?
Cancel out, so it's just 3.
Cancels out. So the denominator is now 3, right?
Square root of 24 over 3?
It is. Square root of 24 over 3. All right. Now, that is an answer. It's a fine answer. It's not a perfect answer because it's not reduced. Because it can be reduced some. How can it be reduced some? Yeah, we go and look and see, is there a perfect square that goes into 24? Is there a perfect square that goes into 24? Yes, 4 does. So we can turn this into, may as well do that part over in our scratch paper area so that we can just keep our work clean over here. Square root of 4 times square root of 6, which would be 2 times the square root of 6. Yep. 2 plus or minus 2 times the square root of 6 over 3. Now, the next bit of this problem is the next thing is generally when we have an answer like this, at this point, because we may need to do something with that answer. And we can't make it not exact because we're math people. We're keeping things exact. And if we end up at some point having to do something with this, it's going to be easier if it's not expanded. So we're going to put them together. How do we add fractions? What has to be true to add fractions?
Have to have the same denominator?
They do. So we need this to have a denominator of 3. So what is 2 with a denominator of 3? 6/3. So our best, most perfectest, most beautiful answer is 6 plus or minus 2 times the square root of 6 over 3.
Anytime there's gonna be a decimal or a fraction in the square root thing, you always wanna separate it.
Mm-hmm.
And so most of the time, you wanna have it in the fraction form so you can.
Yeah. Now, I don't remember, I think I said this in Algebra 2 because it's true then, true in there, but, excuse me. Basically always, your best answer, your best intermediate answer, and your best future answer as far as partial numbers is a reduced improper fraction because it's the easiest to work with later. So if you get a decimal, if you get a mixed number, convert it to an improper fraction. That's the best plan because it's the most useful, easiest to use in other places.
Would you have counted off if we didn't do the 6 over 3 part?
Probably, yeah. Because it's pre-cal. If it was Algebra 2, then no, definitely not. But now I will.
So you always make sure it's the same thing. What if it can't, then
When would it not be able to?
like if you had a 3 on the bottom over there and then like a 7.
It still can.
Yeah,
Because you could multiply this one times 7 over 7 and this one times 3 over 3, and then they would have, then they would both be over 21.
so it's just ugly and terrible.
Yeah. It's likely that textbook problem is not going to do that. But
Can we do like 14 the word problem?
time is
We
it?
have a couple minutes left actually.
I can talk through it at least. Let's see.
Can we talk through how to get the vertex? Because I thought it was just put the.
I thought number 14, the only problem was that the key is probably wrong, and it's probably supposed to be 106.9375.
I got the axis of symmetry by doing the thing, and then taking what I got from axis of symmetry, plugging back into the original equation, and those two answers is the vertex.
Mm-hmm.
Oh, you told me no, so then.
I don't know what I told you. The y-intercept is 107.
Yeah, so it rounded different than I did.
Oh, yeah. Well, and so, like, where to round would be subjective on that problem. So,
Probably though.
so where you would see this problem in outside of math would be in a science class, be in a physics class, or possibly an advanced chemistry class, maybe. But in a physics class, you would look at sig figs. And you would look for the smallest number of sig figs in the given stuff, and so it'd probably be like 1 sig fig or something. So 200.
200?
Yeah.
But it rounds down.
Oh yeah, because the key is wrong. You're right. Yeah. So, and that would be a type of problem that it's like in textbook. It's kind of weird to figure out how many sig figs it really is because you don't usually use the ones in the formula. You usually use ones that are in the given, and so sometimes it's a little sketchy.
This would be right though.
I don't know. Yeah.
There's no extra.
Yeah. Yeah.
I thought that's what it said. Okay.
Yeah. Yeah. No, that would be right.
So I did get that right. So how do you do 30, right?
38. Yes. Typically, I would not count off for this, but usually we write like if there's other stuff in front of the square root, so it's mostly because of handwriting. Yes.
Okay.
I mean that's
I didn't know where I was supposed to put it.
it's not, this is not wrong, and the way you wrote it is very clear what's in and out, but typically it's or so people don't accidentally think that that's in the square root.
Okay.
So that's just more of a, typically we do that type of thing. Okay, kids, go away. I'll see you next week. In the next little bit, I'll have your Google Classroom updated with next week's stuff. So it'll be before the day's out, but it'll probably be much sooner than that.